First one, why is that not a function? Yeah.
Spade isn't in the
Yeah. Yeah, and that's exactly the right one. Since spade is not in the codomain, for comma spade isn't even an element of So that's just a very informal way of talking about this. And you said the word codomain. Oh, isn't in the codomain. Let's maybe jump down. So if you have a function from a set A to a set B, what's the codomain? What does that one mean? Yeah.
all possible things that you could map to.
Yeah, everything that's even like a candidate to be mapped to. And I guess in this notation, it's just B. What about the domain of F? Yeah, the domain of a function, if you're told the function has from A to B, is A. And that's the nice thing about this solver notation. It tells you what the domain is in advance. What's the range of a function? Or maybe say it like informal, and then we'll try to get to a formal definition. And I don't know, maybe this is useful. Let's take the absolute value function. So it's defined for a real number, so it's reasonable to call it the domainer. Each output is a real number, so it's reasonable to call it a codomainer. What's the range of this function? Yeah.
All the points that the function plots to within the codomain.
Yeah, it's let's all write down that exactly. All points in codomain that F maps to. All right, so that looks like a universally quantified thing. So it's the set of all, I don't know, B in B, such that some stuff happens. What does it mean to say that F maps to B? Yeah. I'm kind of happy. Maybe a little bit. I don't know, that doesn't tell me anything about that little b. So what's the relationship you want between that little a and that big B? So that's what it should mean to be in the range of a function. F of A should be equal to B. Let's quantify that, though. Is that like a for absolutely every A, or just there exists some little A that satisfies that?
For every A. You gotta define A, yeah.
Yeah. So for each A in A, F of A is a thing that's in the codomain. So if B is a thing in the codomain, that's in the range. I don't know. 1. So 1 is a thing that's in the range of this function. So which of the following is true? There exists. Because like absolute value of 2 is not 1. So I think over here, it's the set of all B and B. So that's an F of A is equal to B for That definition seems sensible. And we'll write it in a simplified way, so I'll give myself some space up here. It's the set of all B in the set big B, such that B equals F of A for some A in A. Yeah. That seem like a reasonable definition? And we'll introduce another tweaking of set builder notation that will make this shorter to write. You could also write this as the set of all things that look like F of A, such that A is in A. That feel okay? All right, what does it mean to be in the range? It means that you're equal to F of A, and that A has to be in big A. So, aromeric, which maybe isn't so important, those two don't have to be the same, right? The codomain of this function is all of the real numbers, but what's the range of this function? Positive reals, positive. Point is not the same. Is one of them obviously a subset of the other? If you want to compare a codomain and a range, which one's the subset? Range. Everything in the range is also in the codomain, but not conversely. Oh, wait, nope, I saw the wrong one. And I didn't write that in erasable. Range is a subset of codomain. Cool. So, here's a thing that's going to look familiar given the definition of the image. So if I give you some subset of the domain, say there's a set X. The image of X under the function f is all the outputs that correspond to an input in X. Let's put that in formal language. So it's a set of outputs, the set of things that look like f of A,